Chapter 7, Right Triangle Trigonometry. Lesson 7.6. Apply the sine and cosine ratios. So, like tangent was opposite over adjacent, we can come up with ratios that stay the same for each angle that include the hypotenuse. Sine is the opposite leg over the hypotenuse. So here's our angle A. So notice it's sine and then an angle, and it's sine, S-I-N-E, long I, it's not sin, it is sine. Please use the correct words. And then it tells us which angle, that way we know which side is the opposite legs. The opposite's on the other side, and then the hypotenuse. Cosine, again, has an E. It's not cos, it is cosine, it's an abbreviation, is the adjacent leg over the hypotenuse. How do you remember? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So three formulas: tangent, opposite over adjacent; sine, opposite over hypotenuse; cosine is adjacent over hypotenuse. Remember, there's always an angle after the tangent, sine, or cosine. So let's find sine x, cosine x, and tangent x of this triangle. All right, so the angle we're using is that angle. Sine is opposite over the hypotenuse. So go across the triangle. The 8 is the opposite. The 17 is the hypotenuse. So sine is 8 over 17. Cosine is adjacent over hypotenuse. Adjacent is the leg touching the angle. It's never the hypotenuse. The hypotenuse is different. The adjacent is always the leg. And it's 15. Hypotenuse is 17. And tangent of x is opposite over adjacent. Opposite was 8. Adjacent was 15. And you should always check and see if you could reduce these ratios at all. On these particular ones, you cannot reduce the ratios. But we could use them to solve equations. Find the length of the dog run, x. Okay. So from the angle, I know this opposite side, so that's the opposite side. And the x is the hypotenuse. So I have opposite and hypotenuse. Opposite and hypotenuse. Which formula was that? That's right. It is sine. Sine of the angle is opposite over hypotenuse. So our angle is 35 degrees. The opposite is 11, and the hypotenuse is x. Solve this like you solved the tangent problems. Put the sine over 1 and cross multiply. Solve x times sine of 35 equals 1 times 11. Since it's x times sine of 35, we'll divide by sine of 35. And x is 11 divided by sine of 35, which is 19.2, and our unit was in feet. So the dog run is 19.2 feet. You could use these to solve other types of problems. Angle of elevation and depression. Both are measured from the horizontal. So angle of depression is from the horizontal, measured downwards towards your line of sight. So, when you're depressed, you look down. So the angle of depression is from horizontal looking down. Angle of elevation is from the horizontal looking up. Since those are alternate interior angles, they are congruent. So if I ask you to find the angle of depression and you find the angle of elevation instead, that's okay. They're the same size. So depression is looking down, elevation is looking up. So the angle of elevation of a plane as seen from an airport is 50 degrees. If the plane is 1,000 feet away, how high is the plane? Well, let's have a picture. So here is the airport. There's a little tower and the hangar and everything. And the airplane is here. And it's 1,000 feet away, so that's directly the 1,000 feet. So the 1,000 feet is the hypotenuse. All right, so we see what we have. So the x is opposite, and the 1,000 is the hypotenuse. Opposite and hypotenuse, which is that? Is that sine, cosine, or tangent? That's right. It is sine again. Will it always be sine? No. Just my examples happen to be. Sine is opposite over hypotenuse. So I have sine of 50 degrees is the opposite, x, over the hypotenuse, 1,000. Put the sine over 1 so we can do a proportion. X times 1 equals 1,000 times sine of 50 degrees. I put that in my calculator and I end up with approximately 766 feet. That's all there is for today. Have a wonderful day.